In this example, we have 3 points which give us position vectors for A, B, and C. And we want to show that A, B, and C are collinear. In other words, they fall in the same line. So I have my origin somewhere here. I've got a position vector for A. That's my position vector for A, and that's my point A. I've got a position vector for B. That's my point B. And I've got a position vector for C, and that's my point C. And I want to show that A, B, and C are all in a straight line. That, well, if I drew A, B, and C like this in a triangle, they would not be considered collinear. Okay? You can go through all the points in a straight line. So there's a couple of ways that we can do this. Yes? Yeah, I'm just drawing a sort of rough diagram. All of those vectors are in 3 dimensions. So we'd have to imagine in 3 dimensions there's a point over here and another one over here, and then a third one somewhere else, but you could draw a straight line going through all 3 of those points. Okay? So a couple of ways that we could show this. One way that we could show this is we could show that the vector AB is parallel to the vector BC. And if they're parallel, and since they both go through the point B, they would have to be on the same line. Right? You can have parallel lines that aren't on the same line, but then they wouldn't share any points in common. Another thing we could do is we could figure out distances. If the distance from A to B plus the distance from B to C equaled the distance from A to C, then we would know that they would be in a straight line. Okay? So, let's start with strategy number 1. Let's look at the slopes of these lines. Well, we can't really look at slopes because we've got 3 dimensions here, but we can sort of figure out the directions of these vectors. So if I start with A to B, how do I figure out A to B? Well, if this is my position vector A and this is my position vector B, does it make sense that A to B would be a negative A plus B? Or if we, thank you, or if we wrote this as our actual vectors, this would be a negative OA plus OB. And we're given that the position vector of OA is 2, negative 1, 1. So I'll write that as a column vector. And we're given that the position vector for B is 3, 2, negative 1. Putting these together, negative 2 plus 3, this will be 1, 3, negative 2. So the direction of A to B goes 1 in the x coordinates direction, 3 in the y coordinates direction, and negative 2 in the z coordinate direction. Right beside it, we'll figure out B to C. Well, that would be a negative B plus C, which would be a negative O to B plus O to C. O to B was 3, 2, negative 1, and O to C was 6, 11, negative 7. Negative 3 plus 6 gives us 3. Negative 2 plus 11 gives us 9. Negative 1 plus 7 gives us negative 6. So now we've got a direction vector for BC. How do we show that they're going in the same direction? Because the numbers are different. How do we know that both of these vectors do go in the same direction? What's that? If one is a scalar multiple of the other. So a couple of things you could do. You could ask yourself, when I'm comparing these, if they're going in the same direction, then there would exist some value of k that I could multiply this vector by to get this vector.
3, I think.
It is 3.
How about B?
Different variable.
Or Z? Z is nice.
There we go.
No, I was just making a joke about the it was like M and P and I messed it up.
Just because of the letters. So this creates 3 mini equations. One equation is k equals 3, another equation is 3k equals 9, and the third equation would be negative 2k equals negative 6. And as you've noticed already, k equals 3 works for all 3 of those equations. So we can write a statement that since the direction vectors are scalar multiples of each other, they are parallel. And then we know that A, B, and C are collinear. I like using direction vectors to show that they're collinear. It's a little bit less work than the distance formula, but I'll show you the distance formula as well. If you were to find the distance from A to B, the distance from B to C, and the distance from A to C, you would get one of them to be square root of 14, the other the square root of 126, and the third the square root of 224. Now the square root of 126 and the square root of 224 gives us 3 root 14 and 4 root 14. So can you see that AB plus BC is equal to AC? And because those distance adding are equal, you therefore have 3 points that are collinear. No, before. You gotta build up my powers. Yes, I did just write all that instantaneously while talking and pacing.
While I was on my phone. Well, you were wasting time. Wake up. Wake up, you're not in reality.
So now we can imagine A, B, C, D, E as a bunch of points. And you want to go and add these vectors together. A to B, B to C, that's that vector, D to E, that's this vector, and C to D. Well, they all fit together, and from the diagram, this is a starting point, the only starting point that's left. And where did it end? At E. So the answer to this is going to be A to E. We can see that from the diagram. How do we show it mathematically? Well, anytime two letters match in the middle, that will allow you to add them. So AB plus BC becomes A to C. And then, I mean, I'm going to rewrite these, but I might look and say, the order doesn't matter how I write them. I could then put the first and the third one together. AC plus CD would become AD. And then I still have DE. And then AD and DE, that would become AE in the end. I made it.
You made it based on, based on the data.
Just, I had a point, and then there, point A, point B, point C, point D. A to B is the vector from A to B. B to C is the vector from B to C. Yeah, the points could be anywhere, but wherever I draw the A, B, C, D, and E, I will start at A and end at E. So now we have some multiples. We've got two ABs, four ACs, four BAs, two CDs, two DAs, and two DCs. The first thing I want you to notice is this idea. Those ones I'll circle in green. These ones I'm going to circle in red. If you're going 2 in the direction of AB and later you go 4 in the direction of BA, those are reverse directions. Those put together, can you see that the green ones put together are going to be 2BA? The red ones put together are going to be 4 CDs. And I'll just rewrite the rest of the things that we have. 4 ACs and 2 DAs. Do we have any letters that would match up in the middle? Which ones? We have the 4 CD and the 4 AC. The C's would match in the middle. Okay?
Oh, that way, yeah.
Okay?
Yeah, I want to do it that way.
The BA and the 4AC, we can put them together, but we can only put 2 of these ACs together with 2 of these ones. Does that make sense? You can factor certain things out, yes. So like, for example, if I wanted to 2 BAs and I factor out the 4 out of these 2 terms, that will give me, I'm going to write the AC first and the CD next. And those middle 2 will become four ADs. Yes. And then the plus 2 DAs, I'm going to circle those in black. Wow, I missed that circle completely. There we go. There's a better circle. And this will become 2 ADs. Wow. And now those ones match up. I can factor it out. It won't be 4. But if I factor that out, this will become 2 BDs.
Wait,
Yes.
how do AD and DA make their AD?
Well, AD and DA are opposite directions. So if I go 4 in this direction and then 2 backwards, it'll be like I've gone 2 in the direction that I started with. Okay? You can take the time, if you want, to rewrite this one as a negative. And then if you have 4 of them, subtract 2 of them, that would leave you with 2 as well. Yes?
Why did you factor like the first one?
The first 4? Just so that I could show inside the brackets that A to C plus C to D makes an A to D. And the 4 would still be out there.
Whereas the last thing,
I factored the 2 out as well,
just to show that. But
just to show that. I wouldn't need, if you can visualize that as 2 of these plus 2 of those would make 2 of those, that's fine as well.
the numbers don't
The numbers don't
add.
add though.
No, the numbers don't add, but if they're negative, they cancel, won't they?
If they're the same, like if they're the same vector, they cancel. If they're different vectors, you would put those vectors together and then the number doesn't add. I'm going to get you to try the last one on your own. I'm going to go back. We have a rectangle OABC. OA is 8, AB is 6, and so I've really drawn it badly to scale down here, but I've got my OABC. The shorter side is 8 and the longer side in the picture is 6. Everybody okay with that? Excellent.
Not okay with OC being B. That would be affecting the word B.
Yes. Yeah, the OC should be a C, right? Just to mess you up a little bit. Sorry about that. Express the 2 diagonals in terms of A. So one diagonal is O to B, the other diagonal is A to C. Well, to go from A to C, I would have to go negative A plus B. To go from O to B, I'd have to go B plus A or A plus B. And I just decided to write O to B as a column vector there. It would be 6, 8. You go 6 in the x direction, 8 in the y direction. Now, if you wanted to find the length of OB, well, that's just a squared plus b squared, and so we get the length of OB to be 10. Just basically Pythagorean theorem, because you got one side is 6 and one side is 8. Part C asked us to find the length of OB plus CA. Well, if we write out the vectors that we found OB already, that was A plus B. We found AC to be negative A plus B, so CA would be negative A plus B. However, and once you simplify that, you're going to get 2A. Now, looking at our diagram originally, maybe just drawing your diagram, if you imagine OB and then drawing the vector C to A, you can see that you're going 2 in the A direction. Then the length of 2A is the same as 2 times the length of A,
No, just stay here.
Oh, that one.
and that's just 2 times 8, which is 16. And finally, in part D, if you add OA plus AC plus CO, you get, uh-oh, you haven't gone anywhere. A 0 vector.
That's like that.
Gross. Can you show me how you did AC?
How I got AC
Yeah, because
at the beginning?
I got negative.
So if I imagine going from A to C,
Yeah, no, well, I did, because for this part, to show the diagonal, I did CA right away.
oh, you did CA right away, that would be fine.
Does it cancel? So what do you finish with? Go back to C. So then I don't have to put the negative.
But then you would have negative B plus A, right?
Yeah, I got.
Perfect.
Oh, and then it gives 2x.